first ion I'm going to describe begins with the story of someone named Anne. Fortunately, there's no one named Anne in this class because that would be awkward. Anne is a very negative person. Anne is not a happy person. Anne feels like there is a great void in her life. Like there's just some big hole that if she just find the right thing to fill it in, she'd be complete. Kind of like the elements on the right, sort of near right side of the periodic table have a void in their cloud, that if they could just get one more electron, that would fill in their cloud. So what Anne does to fill that void in her outer electron cloud in her life is she attracts negativity. Negativity. And while that does fill in that void, give her a feeling like she has that void filled, she becomes incredibly negative. It's just like anions, anions have a negative charge. Ions, and the reason they're attracting this negativity is to fill that void in their cloud. So Anne is a very negative person. Now, meanwhile, as you probably learned from a couple of my other lectures, I really like cats. The reason I like cats is because you come home after a bad day, the cat walks up to you and goes, meow, 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 meow. And you walk up and you pet the cat starts rubbing up against your leg, and as you pet the cat, an interesting thing happens. All that negativity starts to dissipate away. And the thing is, cats are kind of like the elements on the left side of the periodic table. These ones have one or two electrons in their outer cloud, and if they could just somehow brush away those one or two extra electrons like sodium, beryllium, magnesium, lithium, potassium, calcium, if they could just brush away a couple of those outer electrons, then they'd have a clean outer shell. It's kind of like the cat's constantly licking itself. This is why cats are so intent on this, is they're constantly trying to clean those extra electrons out of their outermost shell. And because of this, when cats succeed in doing this, they develop a positive charge. Think of the cat when it starts pawing you while you're trying to sleep. That is positive energy. Yeah. So it's got a positive charge. Just like cations are positively charged ions. So here's the thing about this. You may wonder, what does Anne and this cute cat have to do with each other? What's up? Well, here's what actually happens. So when Anne encounters Kitty, there we go, let's draw a little bit of Anne. Let's see if we can draw her right. My skills as an artist. Something kind of interesting happens to Anne. Her head all weird, that's okay. Something interesting happens with Anne. When she sees that cat, suddenly she ceases to be negative. She's like, "Oh, kitty, kitty, kitty!" And the cat runs up, jumps up into her arms, is immediately attracted to her, maybe because she smells like, I don't know. Yeah, chicken nuggets, yeah. Chicken nuggets, maybe she smells like bacon, maybe she smells like fish, who knows, but Kitty's suddenly really happy. Kitty looks like a pig in this picture, that's okay. we go. So Anne is suddenly, and so Anne picks up the kitty, and it's like they're happy, they're cuddling, the cat's like giving Anne the happy paws, and I'm pretty sure you're not supposed to pick up a cat like this, but... No. But we'll let that slide for now. Yes. And you know what happens when Anne and the cat get together? They bond. And the bond they form has a special name. We call it an ionic bond. Ionic bond. And so what's happened is the positive charge of the cat, but you know, it's sort of like when you really want to spend time with a cat and somebody's just monopolizing the cat's attention, it can be a little frustrating after a while. Well, so Anne's negative energy is now neutralized by the cat, but the cat's positive energy is also neutralized. You can't hang out with that cat. I mean, we'll talk about what happens when you take the cat away from Anne. It ain't pretty. You don't want to be there when that happens. So the cat neutralizes Anne's negativity, and Anne neutralizes the cat's positivity, and they're inexplicably drawn to each other, and they're bonded forever. And so a good way to remember ionic bonds and the two types of ions that make them is the following mnemonic. Anne is a crazy cat lady. If you have friends or family named Anne, maybe be careful about saying this around them, but we're going to start with that. So let's take another look at this molecule. And what I'm going to do in the meantime is switch over, because now we have the two major types of bondings identified. So let's go back to this molecule here. First of all, you might notice I drew the molecule in a very interesting way. You might notice this molecule kind of resembles a certain celebrity. Ready? M-I-C-K-E-Y-M-O-U-S-E.
Mickey Mouse.
There we go. Exactly. We have Mickey Mouse. The water molecule bears an uncanny resemblance to Mickey Mouse. This has to do with the hydrogen atom being fairly small. At least the way I draw the the water molecule, it looks like Mickey Mouse. That is intentional. You'll see where I'm going with this. And it's not wrong. And this. I kind of need this real estate, so. But is there a pause button on there? Yep. So here's a bit more about the water molecule. So what happens is you notice that because the hydrogen atom's so small, all the electrons are, let's say, what is it? All these electrons are tied up with bonding with the oxygen atom. Something interesting happens. These positively charged electrons are over on one side of the hydrogen most of the time. So over here, you have this positively charged proton, and you have another positively charged proton, and most of the negatively charged electrons are on one side of this molecule, or on the other side of the atom. Which means that Mickey Mouse's ears develop a positive charge. Meanwhile, we have all of these negatively charged electrons at the bottom of Mickey Mouse's face, which gives Mickey Mouse's face a bit of a fairly strong negative charge. You didn't realize that, and so what we call this is a polar molecule. Polar molecule. So here's a little bit more about polar molecules. Most molecules that are this small evaporate at much lower temperatures than does water, and freeze at much lower temperatures than water does. So when you have a polar molecule, something interesting happens. You get these so let's draw a bunch of musketeers here now. And yes, each of these molecules is Mickey Mouse. It's also the water molecule. So what happens is if you have Mickey Mouse's chin sort of with this negative charge, and these ears have a positive charge, then you get sort of an interesting type of bonding. But an interesting sort of thing happens. The positive charge of the ears is sort of somewhat attracted to the negative charge of the chin. And so in the right state, you'll actually form crystals, you'll get these molecules will sort of self-organize and be a little bit drawn and a little bit stabilized. Their kinetic energy and heat will be a little bit stabilized, they'll be pulling on each other a little more. And they're even able to sort of pull on other things around them. And so we call this sort of pull of the polar water molecule, we call it the bond that forms there. It's not a very strong bond, but it's strong enough to manifest a number of important geologic processes. We call this hydrogen bonding. And so, here's now where my favorite part of the story. We're going to go back to our friend Anne, the crazy cat lady, and her adorable little fuzzy friend. So, at some point, someone notices that Anne seems a lot happier, and they ask Anne, "You've just found happiness with your feline friend. What are you going to do now?" And whenever someone asks, "What are you going to do now?" there's only one answer to that question. I'm going to Disneyland! That is what Anne says. And of course, Anne brings her cat to Disneyland. And very quickly, they meet Mickey Mouse, represented by the water molecule. Let's see if we can get this right. Yeah. So when Anne shows up at Disneyland with her cat, remember, here we go, we got the negatively charged chin, we have the positively charged ears. Anne shows up there with her cat. And almost immediately, the cat leaps out of her arms because what do cats like to do to mice? Eat them, chase them. And for this story, more specifically, what I've seen cats in my neighborhood do is they like to bite the face off the mouse.
Oh,
yeah, so here we go. So, oh yeah, those grow back, fortunately, I think. But yeah, I've seen cats do that. Ah! So here's the cat chewing off Mickey Mouse's face because the cat's positively charged and Mickey Mouse's face is negatively charged. So here's the kitty, claws engaged. Ah! He's also doing the bunny kick where kick. Ah. Bite. Ah. This is not looking too good for Mickey Mouse. Ah. Because the cat is immediately charged to the negative charge of Mickey's chin. So meanwhile, Anne, seeing, first of all, now that Anne is separated from a cat, and also because of the positive charge of Mickey's ears, Anne does some other unsavory things. She starts, walks up to Mickey's ears and starts shouting profanities into Mickey Mouse's ears. I'm not going to repeat it because I really would rather not anybody use the language that Anne will use in this particular story towards anyone who's a member of this classroom. So we're just going to draw a bunch of like stars and swirlies and her negative filled tirade that kind of borders and I think I've made fun of enough celebrities this semester. They're sort of, sounds like Sean Spicer's dealings with the press or something like that, or, Scaramucci, yes, that's it. That would outdo Scaramucci. He didn't last very long at his job, but, are pretty intense. In fact, they're so severe that Anne, in her profanity-laced tirade, actually rips off a piece of Mickey Mouse's ear. And now there's, it bleeds.
Zero?
Yeah, she actually rips their ear off with her negativity. The strength of her negativity is enough to rip off that positively charged hydrogen atom from the water molecule. Yeah. And this is how water breaks down ionically bonded substances. This is also why I've been told never to come back to Disneyland again. We can stop recording. Yes.